Hello, this is Lesson 7, Aeronautical Charts and the National Airspace System. So in the most of your training up until you get your glider rating, you'll be operating pretty close to the same airport that you took off from and won't be going very far away very often. But when you get a little farther along and you've got your rating or you start flying with some more experienced pilots, you'll start venturing a little farther from your home airfield, and you'll need information about the airspace that you're going into and the airports that you're approaching. That information is available on aeronautical charts. So we're going to look at aeronautical charts and how to read them. We're also going to talk about the National Airspace System and the different types of airspace that it's divided into, and the different rules that apply in these different types of airspace. And we're going to learn about some of the different rules that other types of aircraft are operating under that are using that same airspace with us. We're going to start by looking at aeronautical charts, specifically sectional aeronautical charts, and the information that's on them. Then we'll talk about some of the difference between visual flight rules, or VFR, and instrument flight rules, or IFR. Then we'll go through the different classes of airspace in the National Airspace System. They're designated by letters, A through G, and in the US we skipped F. Then we'll talk about some special use airspace that doesn't fit neatly into the A, B, C categories. And finally, we'll talk about notices to air missions. So sectional charts are where we get most of the information that we need when we venture away from our home airport. They're available in paper form from a lot of FBOs, and also you can get them from Sporty's Pilot Shops and other online retailers. It cost about $9. They get updated every 56 days, so trying to keep an updated copy can get a little inconvenient and expensive. You can also use electronic versions. One example is ForeFlight. Those are legal substitutes for carrying the paper copies. A little easier to keep up to date. Uh, the only issue I've had using electronic version is that sometimes my iPad will overheat in flight if I leave it in a spot where the sun's shining on it, and the iPad will go off or the batteries run out, and then suddenly I don't have my sectional chart anymore. So let's talk about some of the information that we find on a sectional chart. The first thing we'll find is landmarks that we can use to figure out where we are. Some good information are roads. Here we've got I-94 is a nice 2-lane divided highway. That's pretty easy to look at from the air and know that that's what you're seeing. Also, single lane roads show up on the sectional chart. Sometimes those don't work as well as landmarks because there's a lot of other single lane roads around, and it can be hard to tell whether the road you're looking at is the road that's on the chart. Railroad tracks show up on the chart. They make pretty good landmarks most of the time because there's not that many of them. So when you see one, you're usually pretty sure that you're seeing the right one. Power lines can make decent landmarks, especially in combination with other landmarks. Lakes that have unique shapes, like a couple of these lakes, can be pretty good landmarks, especially if there's some other landmarks around them to kind of confirm that you're looking at the right lake. Sometimes from the air, though, the lake doesn't look quite the same as it does on the aeronautical chart. There might be some swampy area or something near it that you're not sure if that's included or not. Um, Lakes are good landmarks. Groups of lakes are pretty good landmarks, but it's also good to have some other landmarks to confirm that you're actually looking at the correct one. Cities typically make pretty good landmarks, especially because they tend to be located in proximity to other landmarks. And then some things show up on the sectional charts, like the Michigan International Speedway here. That's useful as a landmark because it's kind of a unique thing that we can tell from the air. Now, other things that show up on sectional charts are obstructions. The most common thing that aircraft collide with is the Earth. Um, that's more of an issue with people flying in instrument flight rules, where they're flying in the clouds and hit the Earth. It's not totally totally unheard of in gliders. We do need to always be aware of how high the ground is, so that we keep track of how high we need to be in order to have a certain height above the ground and know when we need to be starting to look for emergency landing sites or land out sites. So the terrain, the colors on the sectional chart indicate the height of the ground. Towers have two numbers next to them. The top number indicates the altitude of the top of the tower in relative to mean sea level. The bottom level number indicates the height of the tower relative to the ground. So if we do a little math, we can also use any tower to know how high the ground in that area is above sea level. Um, Usually when aircraft hit towers, it's the support wires that they hit rather than the tower itself, because those are really hard to see. So anticipate that there are support wires and you need to be, it's better to make sure you're above the tower rather than trying to go beside it. Within each latitude and longitude box on the sectional chart, there's a number in with this form, a big number followed by a slightly smaller size number. That indicates the MSL altitude of the highest obstruction within that box. So as long as we are higher than that, we know we are safe from obstructions. So airborne collision hazards, basically what I'm talking about here is situations where you have to be especially vigilant for colliding with other aircraft. Um, Navigation aids, they're on the sectional charts to help people who are using them for navigation. But even when you're not using them for navigation, you should realize that aircraft tend to converge on those points. So it's better to be avoiding that area if possible, or being especially vigilant there. Instrument approaches, aircraft that are on tend to be on the runway center lines when they're on instrument approaches. So when you're flying past an airport 3 or 4 miles away, the center lines of the runways, extended center lines, are areas where you may anticipate finding other aircraft. Air, Airspace boundaries. So there's certain areas where special permission might be needed to go inside a block of airspace. You find a lot of airplanes congregating just a few miles outside of that. Skydiving jump zones. So skydivers you can't see and avoid skydivers. So when a skydiving jump zone is active, you need to stay 2.5 miles away from it. Um, there are frequencies you can monitor to know whether they when they're doing a drop, but if you think they might be active, I would stay away from skydiving jump zones. So another thing you'll find on the sectional chart, and this takes a little practice to get used to reading it. Um, this is especially important if you're intending to land at another airport to be able to read the airport information block. Uh, it's also important if you're just flying in the vicinity of it sometimes to you can find useful information, or if you're using that as a stepping stone airport for cross country flights, you'll want to be able to get the information you need so that you could land there. So on the left here is a section of the legend from the sectional chart that tells you how to read this information. But the like this example here is for a towered airport. This happens to be the one in Jackson. It has the name of the airport, Jackson County Regional Field. The identifier is JXN. The frequency for the control tower. A frequency for an automatic terminal information service. That's a frequency that tends to provide a lot of information, recorded information about the airport, which is necessary if you're going to land there, but it includes things like wind information, which is useful if you're just flying in the area. It includes information here about the field elevation, 1,001 feet. The airport is lighted. The 53 tells us that that airport has a runway that's 5,300 feet long. And there is a Unicom frequency for this airport. We are in gliders much more likely to use uncontrolled or non-towered airports. The information is a little simpler for those. This is the information for Brooksfield and Marshall. This tells us there is a AWOS frequency, that is automated weather reporting information, which is like the ATIS. It's useful information even if you're just flying in the region without and aren't going to use the airport. Same kind of information about airport elevation and runway lengths. And the 122.8 is the common traffic advisory frequency for that airport. So that's the frequency you would want to use to talk to other aircraft that are in the area using that airport. So there are two different sets of flight rules that are used by aircraft in the airspace system. Glider flying is conducted under visual flight rules. So the rules for visual flight rules in most of the airspace that we use, it's not required to be in contact with any air traffic control facility. And very frequently we aren't. Separation from other aircraft is always based strictly on being able to see the other aircraft and avoid them. Because we need to be able to see them and avoid them, there's a requirement to have a certain amount of visibility. And by visibility, I basically mean how far you can see, which can be limited by fog or mist or smoke or a variety of other things. And we have to stay far enough away from the clouds that if an airplane emerged out of the clouds, we'd have some time to see it and avoid it. The other instrument flight rules, the other set of rules is instrument flight rules. Aircraft that are operating under instrument flight rules, they need to be continuously in contact with air traffic control. And the air traffic controllers are separating them from other IFR flights. But in most of the airspace, the air traffic control is not providing any separation between IFR flights and gliders operating under VFR. They can fly in the clouds, and they routinely do. So that means that they can be emerging from the clouds anytime there's a cloud. So that's why you need to be keeping distance from the clouds. There's 6 different classes or 5 different classes of airspace in the US system. We skip class F, which exists in other countries but not in the US. Each different class has somewhat different rules, and I will go through them uh, later in the this presentation. You don't need to memorize everything on this chart here, but it's just kind of a summary of the rules. So gliders operate mostly in these Class E and Class G airspace, but there are some exceptions. So I will cover A, B, C, and D a little bit in this lesson. If you if you operate a motor glider, which you can do with your glider rating, you'll need a self-launch endorsement. But if you operate a motor glider, then it wouldn't be uncommon for you to go into B, C, and D type airspace. So that's the reason that the FAA requires you to know things about those airspaces to get your glider rating. So we have rules about how far we need to stay from the clouds, cloud clearance, and our visibility rules for flying under visual flight rules. There's sort of a standard rule for the cloud clearance and visibility, which is that you need 3 statute miles of visibility. That's based on trying to give you enough time to see and avoid somebody. There are exceptions to this standard rule for particular airspace classes, but to me it's a lot easier to remember the standard rule and remember the reasons for the exceptions so that you'll be able to remember what the rules are in different types of airspace. Similarly, there are standard VFR cloud clearance rules, which is we should stay 500 feet below, 1,000 feet above a cloud, and 2,000 feet horizontally. So the reason those are different is an IFR flight popping out of a cloud, it would be moving pretty fast horizontally. So if it's coming out of the cloud horizontally, we need quite a bit of space to see it and avoid it. Vertically, they tend to be climbing faster than when they're descending. So that's why the above and below numbers are a little bit different. So Class E, sometimes people refer to that as the everything else airspace. That constitutes the majority of the airspace that our majority of the time gliders will be operating in Class E airspace. In Class E airspace, there's a mixture of IFR flights and VFR flights. We're not required to be using a radio. The other VFR flights are not required to be using a radio, and frequently they're not using a radio or they wouldn't be on the same frequency as you are, even if they are using a radio. Many pilots have something called ADS-B, which is a tool Aircraft that are equipped with ADS-B out will broadcast their positions, and then any aircraft with ADS-B in equipment will be able to see those positions on a moving map display. It's very useful. The problem is a lot of our training gliders and a lot of other gliders don't have the ADS-B out equipment. That means that we don't show up on their screens, and the fact that most airplanes, most of the traffic will show up on their screens has made a lot of pilots get a little too reliant on looking at their moving map to find traffic and not being as diligent as they should be looking out the window. That uh, kind of puts a little extra burden on us to make sure that we are uh, doing our part to make sure we're spotting them. And when we do spot other traffic, we shouldn't assume that they spotted us. There are a couple of frequencies that are used for air-to-air glider traffic, 123.3 and 123.5. When you fly in gaggles with other gliders, um, which you probably won't do too much during your training phase, but it happens more often later, it's good to agree in advance what frequency you're going to use to talk to each other, so that if you're in thermals with you know in close proximity to other gliders, you have an opportunity to talk to them and sort things out on the radio. Below 10,000 feet mean sea level, there is a speed limit that's applicable to most flights. There's a couple, some people get exceptions to it, but that speed limit doesn't apply above 10,000 feet. So above 10,000 feet, other aircraft that you're likely to encounter might be moving quite a bit faster than they would be moving below 10,000 feet. Because of that, the standard visibility and cloud clearance requirements increase when you go above 10,000 feet. They increase to 5 miles visibility required, cloud clearance of 1,000 feet above and below, and 1 statute mile horizontally. So Class G airspace exists under the floor of the Class E airspace. The floor of the Class E airspace is determined by how low IFR flights are allowed to be. So around some airports that have instrument approaches, Class E will extend all the way to the surface. That's what this dotted circle means. So there is no Class G underneath this. Around other airports, the Class E will extend down to 700 feet. Other places it'll extend down to 1,200 feet. There are some places around mountains where the Class G goes even higher than that. Usually when we're in Class G airspace, it's because we're in the traffic pattern at the airport. We really shouldn't be messing around away from an airport at altitudes less than 1,200 feet above ground level. But usually when we're in Class G, it's because we're in the traffic pattern at an airport. Now there shouldn't be IFR flights popping out of the clouds when you're in Class G airspace, because they're not supposed to be IFR flights there. As a result, the visibility and cloud clearance rules are relaxed a little bit. So during the day, it's legal to operate with 1 statute mile of visibility. At night, the 3 statute mile requirement still exists unless you remain in the traffic pattern. As glider pilots aren't going to be doing much flying around at night, but again, the motor glider thing, and you're required to know it to pass the test, so that's why you got to So you have to pay attention to some of this stuff. During the day, you only need to remain clear of the clouds. At night, the same rules apply as if you were in Class E, um, as far as cloud clearance rules. That's, one thing is at night in practice, it's really extremely difficult to know how far you are from the clouds anyway, but that's how far you're supposed to be from the clouds. So when you're landing at an airport in Class G or Class E airport, it will be a non-towered airport. There won't be a control tower giving you any kind of clearance to land or separation from other airplanes. So pilots are responsible for their own separation from other traffic. The main thing we rely on for that is looking out the window. Radio is our secondary thing to help us. So it's recommended, it isn't a legal requirement, but it is recommended that pilots announce what they're doing on the common traffic advisory frequency. You find that on the sectional. The same frequency may be used for a handful of airports that are within radio transmission range. So the frequency that we use at Richmond Field is also used up at Cackleberry and Brighton and a handful of others. So a typical call on the advisory frequency would be something like Richmond traffic, glider 01 Mike, entering left downwind for 36, Richmond. So going through what each part of that means, you start out by saying Richmond traffic. You always start out by saying who you're talking to. You're talking to traffic that's using Richmond Field. Then you say who you are, and usually you start with what type of aircraft you are, because that helps other people know what to look for when they're looking out the window. And also knowing that you are a glider should tell them that you have right of way preference over them if they're operating at the powered airplane. Then you say where you are. You're entering left downwind for 36. Usually follow that with what you intend to do, although when you're entering left downwind for 36, you don't generally need to say because you're planning to land on 36. That's implicit. And then you finish the broadcast by saying Richmond again. You repeat it at the end. The reason you repeat it at the end is that a lot of people who are kind of casually listening on the frequency while doing other things might miss your first mention of Richmond traffic, and they hear the rest of your broadcast and wonder, oh, is that at my airport or is that at some other airport? But when you say Richmond at the end, if they're up at Brighton, then they don't worry about what you just said. If they're also at Richmond, then they should be definitely looking for you. So Class D is sort of the next level up in sophistication of the airspace. Class D is for the airspace around an airport that has an operating control tower, but one that doesn't have radar service. So an example or in the area of Richmond Field, Jackson, Ann Arbor, Pontiac, those are all Class D airports. The Class D airspace usually goes 4 statute miles radius around the airport, and it's 2,500 feet high from the field elevation. So the control tower is providing separation on the runway at a um, at a at the airport. They don't. They're not necessarily separating traffic from each other every place in their airspace, although they do tend to help you find each other. But they kind of sequence people in, tell you, decide which airplane should land first if there's multiple ones approaching the same airport. So the standard cloud clearance and visibility rules apply in Class D. There's no reason why it should be any higher or any lower than the standard. When you're landing at a Class D airport, here are the procedures. The first thing you do is you listen to the ATIS. That is you get the frequency off the sectional. Um, that broadcast will usually tell you the frequency for the tower and the ground control, although you can also get that information from some other sources. It'll tell you which runway they're using, wind information, the information that you need to know when you're coming into the airport that would change sometimes. At the end of the ATIS broadcast, it cycles every few minutes, and they'll give you a Greek letter as the, or not a Greek letter, just a letter as the identifier for that piece of information. Then you call the tower. You should do that. I like to aim for like 8 to 10 miles away. You're required to do it before you get into that Class D airspace, but it's good to do it a little further out. Just because sometimes they'll get busy talking to somebody else and you won't be able to get in the frequency for a few minutes. So you'd say something like Jackson Tower, motor glider 618 Whiskey Delta, 10 miles east, inbound for landing with Oscar. So breaking that down, you start with who you're talking to, Jackson Tower. Next thing is who you are. So that's the call sign for my motor glider. Where you are, 10 miles east. Inbound for landing. So you're telling them what you want to do. And then this with Oscar. Oscar is what happens to be the identifier from the ATIS. So you tell them that you've got that information. That helps them. They don't have to repeat it to you. When tower answers you using your call sign, that means you've established two-way radio communication with the tower. So you need to have established two-way radio communication before you can enter the Class D airspace. But them just answering you with your call sign means that's when you've done that. So they'll give you some directions and you follow them. The directions, usually they'll tell you like a reporting point closer to the airport that they want you to check back in with them. So they will coordinate, if there's several airplanes arriving and maybe a couple that want to leave, they'll coordinate and decide which one should be landing first. They tell you what runway you should use. And when you get close, they will use the magic phrase cleared to land. You have to read back your clearances. And you give your call sign in the readback. So that way they know that you heard correctly what they told you. After you land, you turn off the runway and usually they'll give you an instruction to tell you to contact ground control. So after you've cleared the runway, you would say something like Jackson ground, motor glider 618 Whiskey Delta off runway 332 at Alpha. taxi to the restaurant. So what that means, that's the who you're talking to, who you are, where you are. So you just turned off runway 32 on taxiway Alpha, and then you tell them what you want to do, taxi to the restaurant. Sometimes tower and ground control, especially if it's not a very busy airport, sometimes it's actually the same person, and they will ask you to just stay on the tower frequency instead of getting on a different frequency. If it's a slightly more busy airport, it may be a different person on a different frequency taking care of people on the ground. So you read back the taxi clearance. Uh, if they give you, a lot of times they'll tell you to hold short of something. Often, if you have to cross a runway to get where you're going, they may tell you to hold short of that runway. You have to read that back. And then once you've read back your clearance, you do what they told you to do. You take the route that they told you to take to get where you're going. Um, if they gave you a hold short instruction and you get to that place, probably call them up and tell them that you're waiting there. Um, Oftentimes they're looking out the window and they can see that. Usually they'll give you the an updated clearance telling you, cleared to cross. Uh, Sometimes even before you get there. But sometimes there will be something happening on another runway and they'll have you sit there and wait for a while. When you're leaving a Class D airport, you sort of reverse this process. You listen to the ATIS. It will tell you the frequencies you're going to need to work with. And again, you note that identifier. It might have been updated since you got there because they update them about once an hour. So you call ground control to start with, Jackson Ground, Motor Glider 618 Whiskey Delta, at the restaurant, ready to taxi for takeoff. I forgot to write like with Oscar. You tell them that you've got the ATIS. And it kind of works backwards. They give you a taxi clearance to get to the runway that you're going to take off on, and you follow it. Once you get to that runway and you do your run up if you need to, and you're ready for takeoff, then you call tower, tell them that you're ready for takeoff. At some point, they will clear you for takeoff. So you acknowledge that clearance and then you do what they told you. Class C is the next level of complexity up from Class D. So Class C airspace surrounds airports that have a control tower and also have radar service, but they're not the most busy. They're not big enough that they make it a Class B. So examples in our area would be Lansing, Flint, Grand Rapids. Those are all Class C airspaces. Some extra rules when you fly there. You need a transponder and you need ADS-B out, both to go in the Class C airspace and to go above the Class C airspace. There are some exceptions to these rules for aircraft um, without engine-driven electrical systems, which can apply to some gliders. Uh, but you probably wouldn't be operating in that airspace unless you were flying an aircraft that had the electrical system. So in addition to ground control and tower, there's another type of air traffic controller called the approach and departure control. It's actually the same person. Approach control, we call it approach control when we're flying into the airport. We call them departure control when we're leaving, but it's the same person. And when we're out, even when we're outside Class C, that approach controller can still offer you some services called flight following. Flight following is optional, but it can be a good idea sometimes. So the standard cloud clearance and visibility rules apply when we're in Class C. Class B is the big airports. Um, in our area, Detroit, the area around Metro Airport in Detroit is Class B airspace. It's a lot bigger and it has a lot more stringent rules for operating in it. You need a clearance from air traffic control in order to operate within Class B. So it's not sufficient to have just established two-way radio communication where they answered you with a call sign. You need the magic words that say cleared into Class B or Class Bravo. They use the letter. The um, Since they're providing separation between all aircraft, including VFR aircraft, the cloud clearance rules are relaxed. So you just have to stay clear of the clouds. You don't have to stay a certain distance from the clouds. Transponder and ADS-B out is required not just within the airspace, but actually within 30 nautical miles of the main airport, which is a broader space than what the Class B airspace extends. So, like at Richmond Field, if we go a little ways to the east, we will get to that 30 nautical mile boundary from Metro, even long before we would be having to deal with needing a clearance into the Class B. But again, there are exceptions that apply for aircraft that have no electrical system. So the last type of airspace is Class A. This isn't airspace that's associated with an airport. This is airspace above 18,000 feet mean sea level. There's a few exceptions that deal with mountains that get up into that territory, but for the most part, 18,000 feet is the floor for Class A. So all aircraft must operate under IFR unless they are authorized by air traffic control. So the general rule is that there's no VFR flying in Class A airspace. There are exceptions for wave flying. You might have talked to other glider pilots who talk about wave flying where they get up to 25,000 feet or something. And you wonder, well, how do you do that? Are they IFR? Well, usually the way that happens when there are good wave conditions, there'll be a negotiation with the air traffic control facility, and they make arrangements to have something called a wave window. And gliders will be allowed to operate within that wave window. And there usually will be some special rules. What the rules are depends on what got negotiated with the ATC facility, whatever they agreed to. So you need to get a briefing that tells you what those rules are, and then you need to follow them. So this chart summarizes the clearance and cloud clearance and visibility rules in these different types of airspace. you will you are supposed to know this stuff when you take your written and your oral. But the easiest way to remember all this is to remember the standard rules and then to remember the reasons why there are exceptions to the standard rules in some places. When you do that, it's not as daunting to think to actually memorize all this. So there's some special types of airspace that it's a separate classification from the A through G. Um, some airspace is classified different ways, uh, usually sometimes it's for military use or some activity that happens there. There are air, particular pieces of airspace that are kind of carved out and treated differently. And these areas are marked on the sectional chart. Some of them have periods of time where they're active and other periods of time where they are are not active and you could ignore them. So the first type is a prohibited area. Rules there are real simple. Don't go there. Uh, there's nobody to ask for permission. You just can't go there. The second type is a restricted area. So in a restricted area, you need to get permission from some entity when you want to use it if it's active. Um, Usually that'd be like a military organization. If they're not actually using it at the time, they'll probably give you permission. If they are using it, it's likely that they would say, no, we're not going to give you permission. Another type is a warning area. These are areas off the coast. Um, they when we're flying around Michigan, we don't need to worry too much about warning areas because they exist off the coast. But um, they're areas that you just need to be very aware that there's something going on there that it could be a dangerous place to be. Military operations areas are areas that the VFR pilots are told that you need to use extreme caution if it's active. You're not actually prohibited from being there. You're you don't need somebody's permission, but something's going on there when it's active that could be a hazard to you, like military's doing something there. Flight service station can tell you if a military operations area is active at the moment. National security areas are they're sort of voluntary prohibited areas where you're just requested to please avoid them. Now, something that's started to happen a whole lot since 9/11 of 2001 is this temporary flight restrictions. They've become fairly common. So this is a flight restriction that comes up because there's some reason that the government wants to keep people from flying in a particular area for some length of time. Usually it's something that isn't continuously happening. It's a special thing. One of the common types is presidential movements. When when the president or vice president visit our area, there will be a big radius around wherever they are that you're not allowed to go flying. Stadiums, big stadiums, and our college stadiums count as big enough at Michigan State and Michigan. When there is a game in a big stadium, there's a flight restriction for some radius around it that are not allowed to fly unless you have some permission. If there are forest fires or some kind of other emergency, the government may put a flight restriction over the in the airspace that surrounds that. Um, Usually that's because they're using that airspace to deal with the emergency. There might be firefighting aircraft operating or um, something else going on there that they don't want them to be having to dodge people who are just looking around. So the official source of information about temporary flight rules is a flight service station. 4Flight shows them. It's I've never known it to not be right, but it isn't official information. They usually these flight restrictions get announced at least a few days ahead, but there are some situations where they would be announced on very short notice. Emergencies are the kind of situation where they wouldn't have been able to provide information very far ahead, or sometimes the president will change their plan on short notice and the presidential TFR shows up on short notice. NOTAMs, which officially stands for Notices to Air Missions. That's a system that the government has for disseminating information that's kind of transient information. They don't want to put it on the aeronautical charts because it changes too frequently or it's only a temporary thing. Examples, closed runways or taxiways. So like when we've had snow at our airport and we haven't cleared it yet, we'll close the runway until we get a chance to clear the snow. So they it'll be a NOTAM posted to say that the runway is closed. Sometimes it's maintenance on the runways or something, but short enough term that it doesn't get put on the aeronautical charts. Inoperative facilities, things like runway lights that aren't working, um, glider and skydiving operations. We keep at Richmond Field, we have a NOTAM posted for glider operations basically from April till November. Skydiving operations do the same thing. When they're going to be operating, they put a NOTAM out just to let it gives people information. If there are new obstructions that have come up, somebody built a tower and it hasn't made its way um, onto the charts yet, or somebody's using a construction crane a few miles away from an airport, there'd be a NOTAM for that. NOTAMs, they're available from flight service stations if you call and get an official briefing or electronically get the official briefing. They are also available through services like 4Flight.